Section 9. Introduction to Storage Devices and Media. Introduction. Storage devices perform the fundamental function of storage networks, which is the reading and writing of data stored on non-volatile media. They operate in the microscopic realm, combining advanced magnetic physics, chemistry, and electronics. Demands to increase capacity and performance continue to force the industry to conduct fundamental scientific research on the microscopic characteristics of materials. Storage devices are the building blocks of storage in disk subsystems, as well as being used as stand-alone products in server systems. This study session will focus on the difference between storage devices and media, characteristics of storage media, and factors to consider when choosing a storage media. Learning outcomes. At the end of this study session, you should be able to explain the difference between storage devices and media, explain characteristics of storage media, discuss the factors to consider when choosing any storage media. Storage devices and media. Data to be processed are usually stored in some place in the computer system or outside the computer system. Sometimes, the storage medium is a fixed part of the computer. At other times, they are removable. The characteristics of storage media are explained below. The device that saves data onto the storage medium or reads data from it is known as the storage device. USB ports, CD drives, floppy drives, hard disk drives. Hard disk drives. The hard disk drive has been around for more than 50 years, but it was not until the 1980s that the physical size and cost of hard drives fell sufficiently for their use to be commonplace, though most attention has been paid to the amazing leaps in microprocessor technology described by Moore's law, named for Intel co-founder Gordon Moore, and projecting that the number of transistors on a microprocessor doubles every 2 years. The strides made in hard drive capacity and cost are every bit as breathtaking. Flash drives, memory cards, and solid-state drives. Computer memory storage devices have no moving parts, and the data resides entirely within the solid materials which compose the memory chips, hence the term solid-state. Historically, rewritable memory was volatile in the sense that content disappeared when power was withdrawn and expensive. But beginning around 1995, a type of non-volatile memory called NAND flash became sufficiently affordable to be used for removable storage in emerging applications like digital photography. Storage media. Storage media (SM) are devices that are used in by computers and electronic gadgets to store data. That is, the device that actually holds the data is known as the storage medium. Media is the plural. The computer has many types of data storage media. Knowing what kinds of storage media available can keep you from using up too much space on your computer's hard drive. They can also help keep your computer's hard drive from crashing, along with keeping it running at top speed. The factors to consider when choosing which type of storage media are suitable are cost, capacity, speed. The cost, in the sense that some media are more expensive than others in terms of cost per how much byte it can hold. The capacity, this refers to how much data in terms of byte the media can hold. The speed, this refers to how fast it is for the data stored on the media can be loaded to the main memory for processing. Figure 9.4 shows the picture of some of the common storage media in use. Characteristics of storage media. Storage media have various characteristics and attributes. These are explained below: volatility, mutability, accessibility, differentiation, addressability, capacity, performance. Volatility. Volatility refers to the capability of storage media to retain data after power supply has been cut off. Non-volatile memory will retain the stored information even if it is not constantly supplied with electric power. It is suitable for long-term storage of information. Nowadays, they are used for most of the secondary, tertiary, and offline storage. In 1950s and 1960s, it was also used for primary storage in the form of magnetic core memory. Volatile memory requires constant power to maintain the stored information. The fastest memory technologies of today are volatile ones. Mutability, read/write storage or mutable storage. These are devices that allow information to be overwritten at any time. A computer without some amount of read/write storage for primary storage purposes would be useless for many tasks. Modern computers typically use read/write storage also for secondary storage. Slow write, fast read storage. Read/write storage, which allows information to be overwritten multiple times, but with the write operation being much slower than the read operation. Examples include CD-RW and flash memory. Accessibility. In random access storage, any location in the storage can be accessed at any moment in approximately the same amount of time. Such characteristic is well suited for primary and secondary storage. However, in sequential access, the accessing of pieces of information will be a serial order, one after the other. Therefore, the time to access a particular piece of information depends upon which piece of information was last accessed. Such characteristic is typical of offline storage. Differentiation. Dynamic random access memory is a form of volatile memory which also requires the stored information to be periodically read and rewritten or refreshed, otherwise it will vanish. While static memory is a form of volatile memory similar to the DRAM with the exception that it never needs to be refreshed. Addressability. In location addressable storage, each individually accessible unit of information in storage is selected with its numerical memory address. In modern computers, location addressable storage usually leads to primary storage accessed internally by computer programs, since location addressability is very efficient but burdensome for humans. File addressable. Here the information is divided into files of variable length and a particular file is selected with human readable directory and file names. The underlying device is still location addressable, but the operating system of a computer provides the file system abstraction to make the operation more understandable. In modern computers, secondary, tertiary, and offline storage use file systems. Capacity. Raw capacity refers to the total amount of stored information that a storage medium can hold. It is expressed as a quantity of bits or bytes, e.g. 10.4 megabytes, while memory storage density refers to the compactness of stored information, that is, how much data can be stored in given space. It is the storage capacity of a medium divided with a unit of length, area, or volume, e.g. 1.2 megabytes per square inch. In the past, we had diskettes that were physically the same size but one stored more data than the other, that is, DD versus HD diskettes. Performance. Under performance, we consider the latency and throughput. Latency refers to the time it takes to access a particular location in storage. The relevant unit of measurement is typically nanosecond for primary storage, millisecond for secondary storage, and second for tertiary storage. It may make sense to separate read latency and write latency, and in case of sequential access storage, minimum, maximum, and average latency. Throughput, on the other hand, is the rate at which information can be read from or written to the storage. Environmental impact. The impact of a storage media on the environment include considerations such as energy, that is, storage media that reduce power consumption. 2.5-inch hard disk drives often consume less power than larger ones. Low-capacity solid-state drives have no moving parts and consume less power than hard disks. Recycling. Some devices are made of recyclable materials like aluminum, bamboo, or plastics. Manufacturing. This is the amount of raw materials, metals, aluminum, plastics, lead, used to manufacture the device. Summary. In this study session, You have learned the following. 1. The storage devices perform the fundamental function of storage networks, which is the reading and writing of data stored on non-volatile media. 2. Storage media (SM) are devices that are used in by computers and electronic gadgets to store data. That is, the device that actually holds the data is known as the storage medium. Media is the plural. 3. Storage media have various characteristics and attributes which are volatility. This refers to the capability of storage media to retain data after power supply has been cut off. Mutability. These are devices that allow information to be overwritten at any time. Capacity. This refers to the total amount of stored information that a storage medium can hold. Accessibility. In random access storage, any location in the storage can be accessed at any moment in approximately the same amount of time. Addressability. In location addressable storage, each individually accessible unit of information in storage is selected with its numerical memory address. This is the end of Studies Section 9. Thanks for listening.